In this video, we're going to consider the problems on our review packet where we're asked to solve an exponential equation. In this first problem, we're solving for x, and the first thing we want to do is just undo all the things that are around x, and we can see the first thing we want to do is simply subtract 10. So we get 4e to the x plus 2 equal to 260. Next thing we want to do is divide by 4. So we divide by 4. E to the x plus 2 equals 260 divided by 4. I've got my calculator handy here. 260 divided by 4 gives me 65. And now I need to undo e. And if you recall that if we take the natural log of e, they undo each other. So I can take the natural log of this side and also take the natural log of this side. And I'm choosing natural log because it is the opposite of e. So just a reminder that y equals ln x and y equals e to the x are inverse functions. And that means that when we have the natural log of e to the x, they undo each other and we just get x. So here they undo each other and we get x plus 2 equals the natural log of 65. And our last step is to subtract 2, and I'm going to use my calculator to just get a number. So natural log of 65, and then I subtract 2. And there's my answer. Just drag it over here, and I get that x, I was supposed to go to 2 decimal places, so x is about 2.17. All right, let's look at another problem like this. Here's number 22. So same thing, we're solving for x, it's in the exponent, and we're going to start at this one by dividing by 1200. So let's pull out our calculator and get that number. Clear my screen, here we go. 2700 divided by 1200, and we get 2.25 equals 1.059 to the x. Now in this case we don't have a nice thing like e, and so what we usually do is just take the log of both sides. So the log of 2.25 equals the log of 1.059 to the x. And then we can move that x out front. That was one of our laws of logarithms. You'll recall we learned that the log of any base of a to the k is the same as k times log base b of a. So that k, that's the exponent here, can be written out front. So we get log of 2.25 equals x log of 1.059, and then we just divide to get our answer. Log 2.25 over log 1.059. If we pull this up, we get log of 2.25, close the parenthesis, divided by log of 1.059. And our answer is 14.15 if we round. Now sometimes I've had people go from this step here and right here and say, well, I'm going to rewrite this as, let's see, log base 1.059 of 2.25 equals x. And this is correct, but they get stuck here. So that leads us to making sure we know the change of base law. And the change of base law basically says that log base a of b equals log base k of b over log base k of a. And that k can be anything, and we're going to use a log base 10. So we could go from that to saying, oh, well, that's the same thing as log 2.25, base 10's on our calculator, over log of 1.059. And you would end up with the same answer as here because it matches up with this exactly. So if you rewrote it as a log, you need to go to this change of base where you take the log of 2.25 over the log of 1.059. Now if we go back to the previous problem, I said since we had e we use natural log. I do want to point out we could have done the same thing we just did before. We could have taken log of e to the x plus 2 equals log of 65. And that x plus 2 could go out front. So we could do x plus 2 equals log 65 over log e. And if we did that, you'd see, let's just do this. So log 65 divided by log, and you'll see there's an E right here, second E. And if we did that, we get 4.17. And so we get x plus 2 equals 4.17, and x equals 2.17. So there's another way. Did we have to do natural log? No. We could have done log base 10. But you want to pick one or the other because that's what's on your calculator. Your calculator right here has log base 10 and natural log, which is base E.